Assalamu alaikum students. Uh, Today we are going to start our chapter number, same chapter, application layer chapter number 2, and we are on lecture number 10. We stopped by looking into some application layer protocols or services over the application layer. We have looked in the last lecture on some services on the application layer. Today we are going to start from their comparison, some common application layer services, what are their requirements, okay, transport service, requirements of common application layers. For example, on the application layer, we have the file transfer service, okay, no loss, the application is file transfer, the data loss cannot be affordable by this application, no loss of data, okay, you can't afford loss of data in this application, and the throughput is elastic, whether it is getting good throughput or little bit less throughput, it does not make a very big difference, and this application is not basically time sensitive, okay. It is not necessary that in some tight timing constraints the file must have to be has to be downloaded. Email service can't afford, no loss can be afforded, okay, no loss, okay, can't afford loss. It is also elastic from throughput point of view, and from timing point of view there is no restriction. Web document, web browsing also can't afford data loss, okay, it is throughput requirement is also elastic, and it is also not time sensitive. But real-time video, audio video, real-time audio video, it can tolerate some loss of data. For example, if some voice packets are missed, okay, or lost, it's okay, no problem, just we can't hear that part of the speech, or if some video frames are lost on the way, on the path towards its destination, maximum what will happen, we will skip that frame, that frame will be skipped, we will not be able to see that frame, particular video frame, okay. But there are throughput requirements, minimum values are there for the minimum and maximum for the throughput. For the audio, we do need from 5 kilobits per second to 1 megabits per second bandwidth, okay, or for the video it should be in between 10 kbps to 5 mbps, because usually video frames are heavier as compared to the audio data. That is why upper limit for the video frames are bit more, okay, as compared to the audio, and these applications are time sensitive. That is why, yes, is here in this comparison that these applications are time sensitive, so we can't afford too much delay in delivering video, audio or video packets, okay. These maximum delay can be supported is 100 seconds or milliseconds. This is the tight timing constraints over here, okay. Milliseconds, in milliseconds, hundreds of seconds means millisecond. And interactive stored audio video, yeah, you can even afford, these are loss tolerant, same as above requirement for the throughput, and also these are time sensitive applications. Interactive gaming, yeah, must be same comparison is there. These are loss tolerant, few kilobits of bandwidth is required, and a little bit more than that, and these are also time sensitive. Instant messaging, no loss can be afforded. It is not possible that you type a message and press enter and half of the message is received on the destination and half of the message is skipped. Is it possible? If I write from here, how are you Ahmad, in the messenger and press enter, you are getting how are you, and Ahmad is missing. It can't be afforded over on the destination end. You must have to receive the complete message. So it can't afford loss of data, and it is also elastic. Okay, might be that the message will receive on your end, might be after 1 or 2 seconds, not at the same time immediately. So might be there will be little bit some delay will cause over the network due to some congestion over the intermediary nodes, and you will receive the message after a little bit delay. Yes, these are to some extent these are time sensitive, that the message should be delivered, because it is called instant messaging. At the same time, the message should be delivered on the other side. So that is why you could say that sometimes we say yes and no, mix. Okay, it is mix. Yeah, if it is instant messaging, it should be delivered within the time constraint, tight timing constraints. But sometimes we can say, okay, if it is 1 or 2 or 3 seconds delayed, it's okay, no problem. But usually, I have seen the practice. It is very rare that the messages are being delayed, unless until you write a long text over there. But if these are very small text strings, these can be delivered within the tight timing constraints. Okay. So actually, the comparison here of these applications, why we have done this comparison here, we have to look that some of the application can afford the loss of the data, and some of the application they cannot afford the loss of data. Some applications do need a specific upper and lower and upper bound of the throughput for the bandwidth, and some applications are not very much concerned with the bandwidth. Some of the applications are having very tight timing constraints, and some of the application can afford delay even. So the question is there that if you have this type of applications whose requirements for data loss, throughput and time sensitivity are different on the application layer, what type of transport mechanism do you need at the transport layer? Because the message or the data of these applications will come definitely from application layer to the transport layer. Now the job of the transport layer is to divide this message into segments, because the long message will not be transported as it is over the network. It must have to get a shape, and to give it a shape, the transport layer will divide the message into smaller chunks which are called segments, and every segment will have a header attached to it. In that header, the transport layer will put the segment number, the source port and the destination port, which process is going to transport this segment, which process is going to send this segment, and which process is going to receive this segment on the destination computer, which process on the source computer is going to send this segment, and which process on the destination computer is going to receive this segment. This is the purpose of the port number, and we have discussed the port number in last lecture. Clear? So this information will be carried into the segment header. So now we have to look that every segment for these type of application, different type of applications, how these segments will be transported, by which means. So usually I give an example to my students that there are two type of cars on the transport layer. One is a sedan car and the other is a sports car. So sedan car is a reliable car, safe car. Okay, it is reliable car. Okay, it is a safe car. Okay, and it does not provide the tight. It is not required for this car to be on the destination within a tight timing constraint. It will go safely. That is why it is called reliable. It will establish a connection from source to the destination. It will handle the flow control. But it does not provide the guarantee for the timing and for the minimum throughput. Okay, and it will control the congestion. Okay, so these are the services which will be provided by the reliable transport layer protocol, and the reliable transport layer protocol is called TCP. So TCP is a reliable car, reliable transport layer protocol, and those services which those applications which do need these type of mechanisms while transporting their segments, they will go through the TCP protocol. They will sit in the TCP car on the transport layer, and the transport layer will take care of these things. these issues when the segments of these type of applications running on the application layer have to be transported. So these type of care can be provided only by the TCP protocol, and those applications which are not concerned about these issues, they want to send their segment in a fast car, sports car, and that car is your UDP car. So UDP car will be unreliable because fast cars are usually unsafe, unreliable. Okay, and they don't need a connection setup. They are no more reliable. They will not control the flow. They will not deal with the congestion. Okay, so the UDP services are provided by the UDP protocol on the transport layer for those type of applications which do need the quick delivery, unreliable delivery, fast delivery. So these type of applications segments should be delivered to the destination very quickly, irrespective of any means for reliability. That is why some of the voice and audio packets can be lost over the transportation, during the transportation. So voice and video are type of applications whose segments will be carried on the transport layer by the UDP protocol, unreliable protocol. And email, web browsing, okay, file transfer, instant messaging, these are type of applications whose segments must be transported by some reliable protocol on the transport layer, and TCP is this type of protocol which do provide these services. Connection oriented, TCP is a connection oriented protocol which will set up a connection, and this connection is required between the client and the server process. So for web browsing, for file transfer, for email transportation, first the client computer will set up a connection with the server process. The client computer means the client process running on the client machine will set up a connection, go through a connection setup phase with the server process, and then the transfer of the data will begin. This transfer should be reliable transfer on the transport layer between the sending and the receiving process. If the data is lost, which is sent by the client process and not received on the destination process, server process, the server process will time out and it will send a not acknowledge message that I have not received the data. It means it is lost somewhere on the way. So it means the client process will again retransmit that segment. So that is why it is called reliable. If I am sending you some message and it is lost on the way and you have not got it, you should send me a reply within a specific time period that we have decided in the beginning that my message will be delivered to you within 2 seconds, but now 4 seconds have passed away and I have not received your message. So it seems to be that you have to, it is lost somewhere on the way, and kindly please retransmit it. I am sending you a not acknowledgement message, which means I have to retransmit it. That is why it is called reliable. Clear? Flow control. Sender won't overwhelm the receiver. Sender will not overwhelm, mean it will not overburden the receiver. Whatever is the capacity of the receiver to process the packets, with that much capacity it will be sending only. It will not send more than the capacity of the receiver. So you know that this delivery will not be direct from source to destination. There will be so many hops in between. So the in-between router will be having some congestion control mechanism or the flow control mechanism, dictate to the sender that what should be your pace with which you should inject the packet into the network, so that the flow should be controlled and the sender will take care of the receiver and will not overburden the receiver. So congestion control will be throttle sender with network overloaded. This congestion control mechanism is the job of the flow control. It is dictated by the destination computer, the end computer, and the congestion control will be dictated by the intermediary hops, which are the routers. They are responsible to let the sender know that if there is congestion in between on the intermediary nodes, hops means routers, they will dictate the sender to reduce its value of injecting its you could say its power of injecting the packets into the network should be reduced, so that the intermediary node should not be overwhelmed and can take care of and can process the packets which are already available in their buffer. If more than their buffer capacities, the packets will be coming to the intermediary routers, the packets will start dropping. Does not provide timing, minimum throughput guarantees security. The timing constraints are not very strict, so might be the applications, for example, the email or the web browsing or the file download or the instant messaging will be little bit, the packets of these applications may be face small delay over the network due to not very time sensitive requirements, or the minimum throughput is not guaranteed for these type of applications. Clear? Unreliable services, unreliable data transfer between the sending and the receiving process. They are responsible for the unreliable transfer of the data between the sending and the receiving processes, okay, and does not provide any connection setup, reliability, flow control mechanism, congestion control mechanism, tight timing constraints are there, throughput guaranteed or security. The problem is this, that the UDP protocol is doing less work. That is why you can call it that it does not have to provide a lot of work about these issues, about these things, and the protocol which has to take care of all these things, definitely that protocol has to do more work. So if it has to do more work, definitely this car will go slowly. The car which has to do little work, it will go very fast, definitely. So the passengers who do need quick delivery, they will sit in the fast car. The passengers who do need reliable delivery, no matter even if they are a little bit delayed, so they will sit in the safe car. So TCP is a safe car. TCP is a reliable protocol, safe protocol, which will take care of these issues, and UDP, and it will be used by those applications which do need reliable delivery, okay. But the UDP protocol is that type of protocol which will be used by the applications, those applications which do need quick delivery, unreliable delivery, okay, fast delivery, does not need a connection setup, okay, does not need flow control or congestion control. So these are the basic differences between these two transport layer protocols. Then why we bother? Why is there a UDP protocol? The reason is this: if it is not reliable, in this question it is being asked that why then we use the UDP. We use UDP for certain type of applications which do need quick delivery for voice or video, but for file transfer, web browsing, email, these type of application we do need TCP protocol. Clear? The difference between the transport layer protocols. So applications, email, remote terminal access, web browsing, file transfer, streaming, multimedia, internet, telephony. Now look here on the application layer protocol and their corresponding transport layer protocol, that these application layer protocol will use the services of which corresponding transport layer protocol. For example, email. On the application layer, can you tell me email will use which protocol to transport the email? On the application layer. To transport the email, to send the email, to transfer the email. SMTP, Simple Mail Transfer Protocol. SMTP is a protocol. SMTP is a protocol which is called Simple Mail Transfer Protocol, which is used to deliver the email from the mail client to the mail server, to transfer the, or from one of the mail server to another mail server, because two users mail account, sometimes it is possible these are not on the same mail server. If your mail account is on Hotmail and my email account is on Yahoo, and you are sending me an email, first from your client, the email will go to Hotmail server. Okay, Hotmail from your mail client, and your mail server will send the email to my Yahoo mail server. Clear? So here it will be using SMTP. Then when you will get up, I want to check it, and I will open my mail client software. You use your mail client software to send the mail, and you use the SMTP protocol to transfer the email from, you compose your email and you logged into your Hotmail server, and you use the SMTP protocol to send the email to my email address, and the mail is delivered to my mail server. And when I want to check the emails, I will use the POP protocol to pop up the email, because the email is kept in my inbox on Yahoo mail server. When I will open up my mail client, I will use the POP protocol to get the emails onto my computer. If I will use the web-based email application, I will just hook up here, I will open their website, get into it by giving my login name and password, and I will check my email on their web server, on their mail server, by getting access to their mail application through the web server, no doubt. But if I want to download the email into my mail client, for example Outlook, I have to configure in my Outlook the POP protocol in order to download the POP or IMAP. Two protocols are there to get the emails, to download the emails from the mail server into my mail client software. So POP protocol will go hook up with my inbox, and all the emails it will download onto my computer. So in this way my mails will be saved. These will be on my mail server, not on a third party. It will be on my desktop computer, client computer, not on a third party mail server. So I don't want to keep the emails. If I want, I will leave a copy here, but if I don't want to keep my emails here, there are setting or configuration. You just click that check box. It will ask you whether you want to leave a copy of your messages on the mail server. If you say yes, it will leave a copy there. If you say no, all the mails will be downloaded onto your machines and the copy will not be left over there. So for that, to fetching the email into your computer, you will use the POP protocol or IMAP protocol. Clear? So these are basically, we will look into detail this structure. Okay, so Simple Mail Transfer Protocol is an application layer protocol, and it will use the TCP reliable protocol. Because I told you, is it a practice that when you open your email, half of the email is shown to you and half of the email is missed? No, it is reliable delivery. The whole email will be delivered to you. Clear? So that is why this is due to reliable delivery. The email is going in a reliable car. That is why you are getting the complete email. Part of the email is not missed on the way. It is not lost over the way. Remote Terminal Access Telnet is a service, and it is being accessed on the needs the services of the TCP protocol on the transport layer. Web applications using the remote terminal access basically uses on the application layer Telnet protocol, and Telnet protocol do need the services of TCP protocol on the transport layer. Web browsing on the application layer does need the application layer protocol HTTP, hypertext transfer protocol, and HTTP protocol for the web browsing will use the TCP protocol on the transport layer. Reliable. Remote login does need reliable delivery for its data. Web browsing, the complete web page should open. It does need reliable delivery through the TCP protocol on the transport layer. File transfer FTP does need a reliable delivery. And if you want to look into the details of these protocols, that why do they need a reliable delivery, you can read these requests for comments from RFC website, and these are their numbers for the complete details of these protocols and their bindings with the TCP or UDP protocol on the transport layer. Streaming multimedia through HTTP or real-time protocol is either TCP or UDP. It depends on the application developer, the programmer of the application, that which transport layer protocol services he does need for its applications which he is developing. Internet telephony, okay, the voice over IP telephone, okay, SIP protocol, session initiation protocol or real-time protocol, proprietary, for example, protocol for the Skype. They typically use the UDP protocol. Why? Because the voice packet can't afford delay. They have to be delivered in tight timing constraints, quick delivery. Okay, might be some of the voice packets will be lost over the way, but the delivery should be quick and fast. Clear? Application layer, because TCP has to do a lot of work. So the guy who will do a lot of work on the way, he will reach on the destination with delay. So voice and video are the applications which can't afford delay. So they should go in a car which will not stop at every point and will do a lot of things. It should be quickly go to the destination, quick delivery. So for the quick delivery, as much less work you will do, that much quick you will be available you will reach on the destination. This is the reason. Web and the HTTP, we will look into these are the principles of the network applications and what type of protocols they use on the application layer and what type of protocols they require on the transport layer. We have looked into it. Now we will look into the web and HTTP protocols on the application layer. So from here we will start in the next lecture, because we have a quiz today. So for that I am going to stop it here. Okay. Thank you very much.